So in the previous video, I said that if you want to describe how salty a solution is or how sweet it is, depending on what you've dissolved, if you want to describe how much stuff you dissolved relative to how much liquid was doing the dissolving, this is called measuring or putting a number on solute concentration. And I said there are a bunch of different variations of this equation, and I'm going to show you some of those variations now. So this is going to be a parade of equations, well, 3 equations, small parade. Here's the first member of the parade. The first equation we're going to talk about is called mass percent. Sometimes it's called percent by mass. And the units are written as percent parentheses m/m. Here's the equation. Concentration using this method is calculated this way. You take the mass of your solute, that is the stuff that's doing the dissolving, and you divide it by the mass of everything, the mass of the stuff that you're dissolving plus the mass of the liquid that you're dissolving into, and you multiply your answer by 100, which means it's written as a percentage. And so this is just one way of describing solute concentration, or how concentrated something is dissolved in something else. And here is a sample problem. You can pause the video and try to work through it yourself. One thing that I should point out is that these words are very specific, and that's why I went over these definitions of these words at the very beginning of this collection of lectures. So you have to pay very close attention to what these words are saying. So like I said, you can pause the video and try to work through this. On pausing, I will start to work through this. So the solute is the stuff that you're dissolving, and that is 8 grams of table salt. That is the solute, and we're mixing it with 62 grams of water. So the numerator is going to be 8, or 8 grams, I guess. The denominator is going to be the mass of the solute. That's still 8 grams, plus the mass of the solvent. And solvent for us is the liquid that's doing the dissolving. That's the water. That weighs 62 grams. And so that is going to be simplified 8 grams over 70 grams. That is 0.114. And don't forget, we have to multiply by 100 to turn this into a percentage. And that's going to be 11.4. And the way that we write our answer is we write 11.4% parentheses m/m. And so if I said, hey, I took 8 grams of table salt and I dissolved it in 62 grams of water, what's the concentration using the mass percent method or the percent by mass method? You would do the calculation and you'd say, oh, the concentration of salt is 11.4% parentheses m/m. And what this business here, this parentheses and the percent and the parentheses m/m is telling you is that there are many different formulas that could be used. And so you're trying to tell whoever is listening to you, hey, I used this formula over here. I used this one here and not one of these 600 other formulas that I could have used. That's what those units are there to tell the listener or the reader or whoever you're talking to. So instead of saying my solution is really, really salty or whatever, you can actually put a number on it. You can say it's 11.4% parentheses m/m. Now I want to point out one other thing, and that is that I could have written the formula like this. I could have written the formula like this. I could have said parentheses m/m equals mass of solute divided by mass of solution times 100. And sometimes I write it this way in class, and I say, what's the difference between this and the equation above? They look a little different. If you look at the bottom part here, there's many more words than the bottom part over here. But in reality, the equations are the same, because if you remember, the solution is everything mixed together. And over here, solute and the solvent, if you add them up, that's everything mixed together as well. So I could write the equation for mass percent either way. I could write it like this, or I could write it like this. And you have to know these definitions very well to know that solution means, oh, solution is just solute and the solvent added together. So you have to pay very close attention to how the question is written and how the equation is written. Okay, that's it for percent by mass. The next one is coming up. Next one is very similar. It's called volume percent or percent by volume. And the units are pretty similar again, percent sign, then parentheses v/v. If you look, here's the equation. Percent by volume is equal to the volume of the solute divided by the volume of the solution times 100. And so here's a question that you can work through if you want to pause the video. What's the volume percent or percent by volume of ethanol? That's the booze that gets you drunk. When I mix 7 milliliters of ethanol with 43 milliliters of water, you can pause the video. Unpausing. The solute in this case is the booze, it's the ethanol. It's going to be 7 milliliters. And then the volume of the solution, I'm cutting a little bit of a corner here, but it's close enough to the truth. Basically, you can just, as far as I'm concerned, you can just add these two numbers together because this is the solute and this is the solvent. And if you add them up, you're going to end up with 50 milliliters. And then that is going to be 0.14. And if you multiply by 100, the answer would be 14% V/V. In reality, sometimes when you mix certain liquids together, the total volume doesn't always equal what you think it should equal. In other words, you would think this should equal, 7 plus 43 is going to be 50. You think it should equal 50. Sometimes it doesn't exactly equal 50, but as far as we are concerned, it's going to be close enough that it's not going to make a difference. So if I said, hey, what's the concentration of booze when I go to the party and I spike 43 milliliters of water with 7 milliliters of booze, you could say, oh, it's 14% parentheses V/V, which means we used this method. This is how concentrated the alcohol is in our liquid. If you have ever watched beer commercials, sometimes they'll say stuff like Bud Light is 6% alcohol by volume. What they're doing is they're telling you that, hey, we're measuring how much alcohol, how concentrated the alcohol is in our beer, and we're using this method. We're not using any of the other methods that we could have used. That's why they say alcohol by volume. Another question I should ask is, the M/M percent by mass method is mass of solute divided by mass of solution times 100. And I asked the students, look, why do we need all these equations? Why would I ever use this one as opposed to this one, or vice versa? And the reality is all of these equations that we're going to go over, they have their good points and their bad points. There are times when they're more useful and other times when they're not so useful. The percent by mass equation, that's pretty useful when it's easy for you to measure the weight or the mass of the stuff that you're mixing together. So that's usually when you're going to use that. There are other times when you have liquids and you're just mixing liquids together, and a lot of times it's easier to measure the volumes of those things. And so a lot of times when you're measuring liquids, you'll use percent by volume instead. So all of the equations that I'm going to show you, they have their good points and their bad points. The third equation, and the last one in this video lecture, is kind of a mix between the first two. It's called mass over volume percent, or percent M over V, percent parentheses M over V. And it has very specific units. So percent M over V is the mass of the solute, that's the stuff you're dissolving. Units have to be grams. And the volume of the solution, that's the entire mixture, has to be in milliliters. Those are the only units you can use in this case. And so here's another sample question. What's the mass volume percent when you take 14 grams of table salt and you mix it with water and you make 143 milliliters of solution? You can pause the video and work through that if you want. Unpausing. So our solute is table salt, and nicely enough, we already have the mass of the table salt in grams, so our top number is going to be 14 grams. Volume of the solution in milliliters, well, look here. It says solution, 143 milliliters. Easy enough, times 100. This little part here is 0.0979, and times 100 to turn it into a percentage. And we'll get 9.79% m/v. And so if I said, hey, how salty is this when I take 14 grams of table salt, I mix it with water, and the final volume is 143 milliliters, you'd say, oh, the concentration of table salt is 9.79% using this parentheses m/v, or mass over volume percent. So again, this is just a number to describe how salty that liquid is. And if the number gets bigger, it's saltier. If the number gets smaller, it's less salty. And that is it for the first three equations. The last equation gets its own video because everybody hates it, so I'm going to treat it extra special. Okay, bye-bye.